Okay, so let's kind of just review what we did. We took what we knew from geometry, our sine and our cosine. We know that sine is the opposite leg over the hypotenuse. So if we're using our little reference angle here, opposite was our y over our radius, okay, which is right here. But we know that, in fact, the radius is a 1. Therefore, we get sine is our y. Okay? And then if we go back to our cosine, cosine is the adjacent leg over the hypotenuse. Our adjacent leg in this case is the x over the radius. But again, we know that that radius is 1, and so we get that, in fact, our cosine is the x. So that gives us the ordered pair of cosine, sine. So now what we're going to do is we're going to go back to our unit circle, and we're going to label our x as the cosine and our y as the sine. Okay, so get your unit circles out. We're going to change that back. So on your unit circle, somewhere on it, I don't want you to label all of them. Maybe just label one. You know that that's going to be your cosine and that that's going to be your sine. You could come down here and just do it once. I could do my cosine sine. Somewhere on your unit circle, distinguish that your ordered pair will be converted to cosine and sine. Okay, using the unit circle, we want sine of pi over 3. So go over to your unit circle, your pi over 3, go find that, which is right here. We want sine, so which value in your ordered pair are you going to use? The 3 over 2. So sine of pi over 3's exact value is the square root of 3 over 2. And that's how we use our unit circle. Okay, cosine of 135. So find your 135, which is over here. You want cosine, so which value are you going to use?
Minus.
The minus. Good. So that would be the negative square root of, oops, I wrote the wrong thing. Square root of 2 over 2. Okay? That makes sense? Okay, so if we wanted cosine of 45, I'm going to go over here and find 45 cosine. Did you use the x or the y? The x. So you had square root of, let's change color. You had square root of 2 over 2. Okay. Alright. Our next one was sine of 2 pi over 3. So find 2 pi over 3. What quadrant was that one in? Second. So here it is. You wanted sine. So which one did you use? You used which one?
The y.
The what? Oh, I thought you were saying pi. Yes. Very good. So that was the square root of 3 over 2. I was wondering where you got the 5. Square root of 3 over 2. Yes, we use our y. C, we have sine of 180. So, well, 180 is just our axis, right? Sine, which one did you use? Again, that one was right. So that one is 0. And then our last one was cosine of 7 pi over 6. What quadrant is 7 pi over 6 in? Third one. He's right here. You wanted cosine, so which one did you use? X. So that was a negative square root of 3 over 2. All right? How do you feel about that? Okay, so if we want to find tangent, tangent of that little reference angle, this guy right here, we're going to use our opposite leg over the adjacent. So that would be what? So opposite would be y over x. Well, actually, We found y to be what? Sine. And we found x to be cosine. Did we not? Okay. So we can find tangent, which is our sine over our cosine. And just a side note. So pi over 6, go to your unit circle. What is the ordered pair that is connected to the pi over 6? Okay. So that is the point that's associated with that pi over 6, or that is also 30 degrees, right? So now let's find, we're going to find the tangent, which essentially is the slope, and we just talked about that being the line tangent at that point. So if I want to find tangent, I know that that's going to be my sine over my cosine, right? Okay. Which one is the sine? The 1/2, so I have the 1/2 over the cosine of the square root of 3 over 2. So I've got a complex fraction, so let's just rewrite that as division. Makes it easier to work with. So that's the same as 1/2 being divided by that square root of 3 over 2. Now, how do we divide fractions? Multiply by the reciprocal. Yes, thank you. So we're going to continue. So that's going to be 1/2 times 2 over square root of 3. What can we do with a 1/2 times a 2 over square root of 3? Yes, what can we cancel? The 2's. So we cancel the 2's, they will cancel and go to 1, and then we would end up with, in our numerator, 1 over, and in the denominator, square root of 3. All right. We also learned in geometry that when we did this, we could not leave the radical in the denominator, right? Because your radical really is not an exact number. So we need to rationalize this denominator. Who remembers how to do that? How are we going to get rid of the denominator? Could do what with it? No, negative. The negative 300 would be imaginary. It's real. It's just not exact. It's not like a true point. How do we get rid of that square root? How do we get rid of square roots? What? We square. Essentially, how do we get rid of square roots? We square them, right? So if I want to get rid of this square root of 3, I essentially am going to square him by doing what? By multiplying him by himself, right? And I can't change the value of this thing, so we have to multiply with our special 1. So we have to do the same thing in the numerator. So essentially what happens, so I have a square root of 3 times a square root of 3, right? In other words, is that square root of 3 squared? Is that the same thing as taking the square root of 3 and squaring it? Yeah, it is. It's the same thing. Because if I do this, my square cancels my root, and what am I left with? 3. Now, if I went over here and actually did the multiplication, the square root of 3 times the square root of 3 would be the square root of 9, and the square root of 9 is 3. So essentially that is what we're doing. We're using its inverse. So in the numerator, 1 times the square root of 3 would just give us square root of 3, but in the denominator, we got rid of the radical, which was what we wanted to do, right? We wanted to get rid of it. So that's our slope. That is also our tangent. And if we actually did the multiplication on this 0.5 something, if we go ahead and divide that out, it's actually 0.5772, I think, or something like that, and we would round that off. Okay. A little bit more work on your tangents because we've got those radicals to work with. Okay, the 135, if you wrote that as your sine over cosine, would you get a square root of 2 over 2 divided by negative square root of 2 over 2? Is that right?
Yes.
Okay. So if you rewrite that and then take the reciprocal, you got the square root of 2 over 2 times 2 over the square root of 2. This one is, in fact, negative. Okay, so I'm going to put that negative in. And then what actually happened in this case? They all just canceled out, didn't they? So, and when we cancel out, they don't go away. They go where? They all became what? 1s. So your final answer would be -1. So that makes your exact slope and your approximate easy as well. Okay? And then our last one, our 4 pi over 3. So if you wrote that, you had negative square root of 3 over 2 divided by, and I'm going to go ahead and flip it and check me, make sure I do it right. And then if we get negative 2 over 1. Did I do it right? So this one's kind of nice. You don't have to mess with the denominator, do you? So what happens to your 2's? They cancel out. Well, canceling. And so those are gone. They go to 1. They're not gone. I shouldn't say that. They go to 1. And also, what's a negative times a negative? Positive. So our answer is positive square root of 3. Okay. Any questions on that? All right. Next thing I want you to do is I want you to go down and do number 7 and 8 with your partner. Tangents of 0. What is your ordered pair that goes to 0? 1 and 0? So that ended up being 0 over 1, and 0 divided by 1 is 0. So tangent of 0 degrees is just 0. All right, now let's take the tangent of 90. What's the ordered pair that goes with tangent of 90? Sorry. 0, 1. Okay, so now we're going to have our sine over cosine of 1 over 0. What is 1 over 0? Undefined. Remember, we talked earlier that tangents we're really talking about the slope, right? And 1 over 0, remember, that's impossible. We can't divide by 0. And you learned that, which lines have an undefined slope? Verticals or horizontals? Verticals or horizontals? Verticals. Right, your vertical lines are undefined. Okay. And on number 8, compare the values of tangent 0 and tangent 180. Well, we already found tangent of 0. What was tangent 180? What's associated with 180, the ordered pair? -1 and 0. So that ended up being sine over cosine, which would be, it's 0 divided by -1 would still also just be 0. It won't be undefined, it'll be 0. Only undefined when the 0 is in the denominator. Okay? So just be wary, be careful. You will sometimes come up with some undefines, and then when we bring in the reciprocals, you'll find a couple of them there as well. Okay? So what this means, the next thing we're going to do is we're actually going to graph these things, right? So do you see kind of what's maybe going to happen here? You think we're going to have, when we go to the, when we have undefines, how do we show that on the graph? That's going to be where we have what? We have 0 in the denominator. We're going to have what? We're going to have some asymptotes, right? We're going to see some asymptotes again. Yeah. Okay. What's the measure of that one? 168? Okay. Right. And how can you find that? What did I do to find that? Or Shadrach found it, actually. Well, if we know that that's 12, we know that we've got to get to that 180, right? So it's just essentially that you could have taken the 12 and subtracted the 180 from it, right? So now, here's what I want you to do. Tell me, okay, here's our point. What is that ordered pair here? So if we're over here, that in quadrant 2, that's our negative positive combination. So it's going to be what? Negative 0.978 and then the positive 0.208. Very good. Okay, let's finish this up. So if I'm down here in quadrant 3 with a reference angle of 12, how far did we go? Now let's keep it, oh, you're doing the points, but what's this angle here? That would be the 180 plus 12, which would be what? That'd be 192, all the way there. Okay, now tell me the ordered pair. What combination is this ordered pair?
Negative.
Yeah, negative, negative. So negative 0.978 and negative 0.208. And let's go all the way around. Let's see, let's do some red here. Let's go get our reference angle here of 12. That means we had an initial angle of, what's 3? We just subtracted that from 360. What would that give us? 48. So what would the ordered pair coordinates be for this one? Positive, negative combination. Good job. So this would be positive 0.978 and negative 0.208. Very good.
You want to give it back?
Oh, you can give it back to me. Because they're not doing. If you went down, yeah, right. Yeah. Okay, you're welcome. Good luck.
Spencer, take our books, right?
Yeah.
Yeah, I was talking. It's like, my brain.
Did you pick up the book section?
Yeah, and you need to take this with you. Okay? You don't want to keep things that clear out. Yeah, you're responsible from now on. So it's the ones that left are right there. Okay? Do that for me. Thank you.